Okay, so we talked about if a was greater than 1, but what about if a is between 0 and 1? So if it's a positive fraction. Well, let's do f of x is 1/2 to the x and g of x is 1/3 to the x. Then we have 1/2 to the negative 2 is 4. 1/2 to the negative 1 is 2. 1/2 to the 0 is 1 because anything to the 0 is 1. 1/2 to the first power is 1/2 and 1/2 squared is 1/4. So if we graph that, we have negative 2, we have 4. At negative 1 we have 2. At 0 we have 1. At 1 we have 1/2. And at 2 we have 1/4, which it gets hard to graph, but that way, and kind of slopes up this direction. Pretend I actually hit the points. Okay, for 1/3 to the x, 1/3 to the negative 2 is 9. 1/3 to the negative 1 is 3. Anything to the 0 is 1. 1/3 to the first power is 1/3. And 1/3 squared is 1/9. So again, I'm going to change colors here. So at 2 we have a 9th, which is even below a 4th. It's hard to get in there. At 1 we have a 3rd. Okay, our 0, 1 point is the same. At negative 1 we have 3, and at 2 we have negative 2 we have 9. So it looks like that. More or less, you know, forgive the bad graphing. And of course the black one is f of x. So, why do they decrease when the graphs in one increased? Well, they decrease because our growth factor, a, was between 0 and 1. So what are the domain and range? Well, for f of x, the domain is negative infinity to infinity, and the range is still 0 to infinity. For g of x, same thing. The domain is negative infinity to infinity, and the range is 0 to infinity. Can y equal 0? No. Why? Same reason as before. Any positive number raised to any exponent is still positive. Does the function have symmetry? Nope, just like the other one. So what are the x and y intercepts? For f of x, there's no x-intercept, just like before. And the y-intercept, just like before, is 0, 1. For g of x, it's exactly the same. There's no x-intercept. And the y-intercept is the point 0, 1. Do they have a horizontal asymptote? Yes, yes they do. And its equation is y equals 0 again. Okay, moving to the next page. This just sums up the properties for if A is between 0 and 1. So what do we have? Well, the domain is negative infinity to infinity. The range is 0 to infinity. There are still no x-intercepts, and the y-intercept is 0, 1. The x-axis, or y equals 0, is a horizontal asymptote, this time as x approaches infinity. So as x gets bigger, it gets closer and closer to the y-axis. On the other ones, from the last lecture, piece of the lecture, as x got smaller, y got smaller. So this time when a is between 0 and 1, the function is decreasing. And the graph contains the points negative 1, 1 over a, 0, 1, and 1a. And of course it's smooth and continuous and has no corners or gaps. So that smooth means no corners or gaps. Well, smooth means no corners. Gaps is from the continuous part. Sorry. Okay, moving on to the next page. So how do we graph these using transformations? Well, let's see. The -2 means we have a vertical shift down 2. The +1 in the exponent means we have a horizontal shift left 1. So if we take our curve from before and we do our shifts, we know we always have the point negative 1, 1 over a. So that would be negative 1, 1/2. So if we take negative 1, 1/2 and move down 2, 1, 2, and left 1, that point moves to right there. Okay, we always know we have the point 0, 1. So if we move down 2 and left 1, that point is now right here. And we always know we have the point 1a. So in that case it would be 1, 2. And we move that down, we move that down 2 and over 1. And it's right there. Now, our horizontal asymptote also moves down 2. So it's now right here at -2. And so our graph, we just make that same curved shape, something like that. So our domain is still negative infinity to infinity. The range is now -2 to positive infinity because we shifted down 2. And our horizontal asymptote is at y equals -2. Okay, so what about this next one? -2 to the x. Well, the negative in front of the 2 means we reflect across the x-axis. So, our point -1, 1/2 becomes -1, -1/2. Our point 0, 1 becomes 0, -1. And 1, 2 becomes 1, -2. And we just try to connect the points. So, since all we did was reflect, our horizontal asymptote stays at y equals 0 because we did not do any shifting. So our domain is still -infinity to infinity. The range is -infinity to 0. And our horizontal asymptote is at y equals 0.